Hello everyone, so welcome back. So from today onwards we'll start the new lesson, that is determinants. Okay, so in determinants only one principle you have to learn: how to operate or how to solve a determinant. Okay, so once you learn that, you can easily solve all the problems from determinant part. Okay, so we'll see. So I know that most of you have started this chapter in your schools. Okay, so your teachers may be taking the principles, everything very nicely. Okay, so along with that we can solve few more problems. Okay, so for your exam point of view, so let's start doing. So this is our first problem. So we need to solve a determinant. How to solve a determinant? So first of all, you need to keep in mind this is a two dimension. Okay, so we have only, it's a square mode determinant, right? Because we have only 4 elements. So how to solve this? First of all, you have to make, since this is a square determinant, we just need to make any of this element 0. Okay, I will say you what is the advantage of that. So first of all, we will do a column base operation. So C1 we will change as C1 minus C2. So this is C1, this is C2. Okay, so we are going to do a column base operation. So C1 minus C2. So C1 minus C2 will be C1 minus C2. So x square minus x plus 1 minus x minus 1. Then this column will be the same, no change. X plus 1 minus x plus 1 will be 0. Then x plus 1. Okay. So here x square and 2x is there. Minus x will be minus 2x, right? And we have, okay, yeah, there will be a bracket, right? Because this negative is applicable to both the elements. So minus into x will be minus x. So minus x in minus x will be minus 2x. Then minus of minus 1 will be plus 1. So when we remove this bracket, it will be plus. So 1 plus 1, 2. So we can write it as minus 2x plus 2. So we'll get like this. Okay, so you can just see here what is the next step of operation in a determinant. What we will do? We will just cross multiply, right? So if we multiply any element with 0, what will happen? So the whole thing, the term which is multiplied with 0 will be 0, right? So you have to do this determinant operation in such a way that if we have a 3-dimension determinant, then try to make these two or these two elements 0. So it will be easy for you to solve the determinant. So you just need to consider only one element. Okay, so because if you so I will just explain you the operation. So in this case, our next step is, this will be same for all square determinant. Okay, so this will be x square minus 2x plus 2 into x plus 1. Then 0 into x minus 1 will be minus. So our, once we multiply one pair, then put negative. Okay, then the next pair. So 0 into x minus 1, that is 0. Okay, so our answer will be x square minus 2x plus 2 into x plus 1. So this will be our answer. Clear? So if you make an element 0, you will get a benefit. Let's see our next problem. Okay, so this is a 3-dimensional determinant. Okay, so here so first of all we can just remove all the complexities. If you look at this determinant, we have some square terms. Okay, so we can take x square, y square and z square as common from the determinant, right? So you need to mention here taking x square, y square, z square common from C1, C2 and C3. Okay, so you can see here in column C1 x square is common, right? 0 term no need to consider, and in C2 y square is common, so we can take that, and C3 z square is common. Okay, so what are the remaining terms? So we have x, y, z. Okay, now so I have already told you that if you make any of the 2 elements in the first row, it will be easy for you to solve the determinant. So if you see here, one term is already 0. If I make this term also 0, we'll see what is the advantage of that. So for making this 0, what we will do, C2 we need to change as C2 minus C3, right? If we do that, we will get, so first column will not change, the same. Second column x minus x 0. Also third column will not change. 0 minus y minus y. Z minus 0 z itself. So we'll get like this. Okay. Now you see, for a determinant, what is the next operation? For a 3-dimension determinant, the next operation is this term into, okay, so we'll take the term and the corner part of the determinant. Okay, so 0 into, we'll consider the square determinant. Okay, so for a 3-dimensional determinant, we'll consider the element in the first row and the corresponding square determinant at the corner. Okay, so 0 into, we will do here minus y into 0 minus z into y. This is our basic operation of determinant. So 0 into minus y into 0 minus, okay, z into y, z into y. Similarly, if we consider the second element, this element, so this element if we consider, we will not consider the elements in the same column. Okay, so similarly if we consider the first element 0, the corresponding column elements we will not consider. Okay, it's a trick you can keep in mind. If we consider this term, we will not consider the elements in the same column of that term. Instead of that, we will consider the other 2 column terms. Clear? Similarly, if we consider this term, the same column elements we will not consider. We will do the cross operation with the first and the third column elements. Clear? So we will be considering this 2 terms and these 2 terms. So it will be plus 0 into y into 0, okay, minus z into y. Clear? Okay, similarly the third one. So if we consider this term, we will not consider the elements in the same column, we will only choose the square determinant at the corner. Okay, we will not consider the elements in the same column. For x, we will consider the opposite corner determinant terms. Okay, so for x, it will be, so for determinant, the sign when we put, if the first sign is plus, then the next sign will be minus. Likewise, it has to go. Okay, so for a determinant, so first sign is plus, right? So the second, when we do this operation, okay, first considering this element, right? So that is plus. Then if we consider the second term, these two columns, then it will be minus. And again, if we consider the next element and this determinant, it will be plus. Okay, so likewise, alternately the sign has to change. Okay, so these are some simple things you have to keep in mind. Okay, so sign of these operation will change alternatively as we consider each element. Clear? Okay, so x into, so this is the order. Okay, first this one and this one, or when we do, if we consider these two, first do this one, then this one. Okay, so this is the order. So yz minus z into minus y, it will be minus zy, right? So we can, so minus zy, so minus and minus will turn as plus. Okay, so since these two terms are 0 multiplied with 0, so both these will get cancelled. So finally we have a x square, y square, z square outside the determinant, right? Into x into yz plus zy, both are same only, yz. Okay, so this will be our answer. I hope you are clear with the process or the procedure for solving the determinant, right? So each element will consider, we will avoid the same column elements, we will consider the other two. Take the next one and similarly avoid this one, take these two. And third one will avoid the similar column terms, then take the other two. Okay, and here what we will happen, what we will do, this term into this order. Okay, cross multiply yz minus these two. Okay, also keep in mind alternatively when we consider each element, sign also will change. Okay, if you are clear with these procedures, you will be easily solve determinant problem. Next problem. So here again we need to solve this determinant. Okay, so suppose I am doing an operation C1 as C1 plus C2 plus C3. Okay, can we do that? So let's see what will happen. So C1 only will change, other two columns will be the same. Okay, y minus 2 minus x plus z z minus y 3z. Okay, so 3x plus minus x plus y, right? So minus x plus y, again minus x plus z. Even if we put plus here, plus minus, then again it will be negative, right? So here x minus y plus 3y plus z minus y. Okay, so here z x minus z plus y minus z plus 3z. Okay, so we are solving this. So this is going to be 3x minus x is 2x. Again minus x, x. So x remaining is x and z, y and z. So x plus y plus z. Similarly here minus y plus 3y is 2y. Again 2y minus y is y. So again there will be x plus y plus z. Here x minus z plus 3z will be 2z. We have again minus z. So 2z minus z will be z, right? You can check there. So the remaining terms will be x plus y plus z. All these negative operations, how to handle it, we already learned. Okay, that is why I am not repeating. Why I am telling this again and again. Those who are attending this for the first time, go through the lessons, the prior lessons, okay, and understand it. Okay, so those who are regularly getting these lessons, they can easily solve this. Okay, minus x plus y, 3y, y minus z, then minus x plus z, z minus y, 3z. So next we got the similar terms, right? So how to make, somehow we need to get zeros. In these column only we will get zeros, right? Because all others are different terms. Okay, so take x plus y plus z outside from here, right? Yes, so it will be x plus y plus z outside, then the remaining will be 1, right? Then minus x plus y, 3y, y minus z, minus x plus z, z minus y, 3z, right? So we can easily make any of two elements in this column 0, right? So for that I am just applying an operation. Okay, so suppose I am doing R2 as R2 minus R1, R3 as R3 minus R1. Let's do these two operations. Okay, so the first row will be the same, 1 minus x plus y minus x plus z. Okay, now so R2 minus R1, so 1 minus 1, 0, then 3y minus minus x plus y. Okay, then okay, so z minus y, z minus y minus of minus x plus z, right? Okay, so similarly R3 as R3 minus R1, so 1 minus 1, 0, and y minus z minus of minus x plus y, then 3z minus of minus x plus z, right, plus z. Okay, so what we are going to obtain from here? So 3y minus of minus x will be plus x, minus of plus y will be minus y. So plus x minus y. Okay, so this will be 3y minus y will be 2y. Here minus of minus x will be plus x, minus of plus y will be minus y. So this will be plus x minus y. So y minus y will be 0. Here minus of minus x, again plus x and minus y, minus z. Z minus z will be 0. Now here minus of minus x plus x minus z. So 3z minus z will be 2z. So these will be our elements in the determinant. Now how to solve this determinant again? So if we consider this term, we cannot consider these, we will be operating these determinant elements. Okay. Similarly, if we consider this element, we will avoid these elements, we will operate these two. Okay. So anyways, we don't want to consider these two elements because anyway the answer is going to be 0. Just take 1. Okay. Before we have x plus y plus z outside, 1 into. So for 1, if we consider 1, we will avoid these two, we will only take these. Okay. So 1 into 2y plus x into 2z plus x. Okay. Minus z plus x into minus y plus x. Okay, we will get like this. So now we need to simplify this term. Multiply 1 with any element, it is going to be same, right? So x plus y plus z, then multiply these two. Okay, so first of all consider 2y. Okay, multiply 2y with these two terms. We already learned how to multiply this. So 2y into 2z plus 2y into x plus x into 2z plus x into x square minus okay, so we can just rearrange this as x minus z. Also here it is x minus y. Okay, so minus x into x, x square, x into minus y, minus xy, minus z into x, minus zx, minus z into minus y plus zy. Clear? Okay, so if we apply this negative inside, this negative is going to be plus, this will be going to be plus, this will be going to be negative. Now we can remove this bracket. Sorry. Okay. So from here 2 into 2y into 2z, so it will be 4yz plus, here it is 2yx plus 2xz plus x square. Okay, minus we have x square plus xy plus 2z minus 2y. Okay, So have a small correction, it is not z, it is x. Okay, so it is also x. So now 4yz, okay, we have 4yz. 4yz minus yz will be 3yz, right? 3yz plus. Okay, so here we have a plus x square and minus x square, so both will get cancelled. Okay, clear it out. So 2yz plus yz, so 2yx and xy will be 3xy plus 2xz and xz, 3xz. So this will be our answer. So simplification is easy if you are doing it carefully. Okay, so deeply I have explained the procedure for handling negative numbers, negative sign. Okay, so please go through it. I am sure if you are not careful while solving this, definitely you will get the wrong answer. Okay, so please go through the sessions carefully and understand. Okay, once you get the clear idea, you can solve any problems. So this will be a solution for this question. Okay, I hope you understand the trick of the determinant. If it is a 3-dimension determinant, make any of 2 elements 0 in the first row or the first column, then you can easily solve it. Okay, so let's continue our solutions.